Hi everyone, so in this video we'll be discussing the volume of solids of revolution using Washer's method. Okay, so let's start. Let's start. For the first problem, we want to find the volume of the solid generated when the plane region bounded by the parabola y equal to 2x minus x squared. So in the graph, this is the parabola. And the line y equal to x minus 2, so this is the line, is revolved about the line y equal to 2. This is y equal to 2. Okay? So first, we want to recall the formula for the volume of the solid using Washer's method. So V, for the volume, is equal to the definite integral of pi times r sub 2 squared minus r sub 1 squared d omega from A to B. Okay? So in this formula, R2 is simply the distance of the farthest tip of any arbitrary rectangle to the axis of revolution, while R1 is the distance of the nearer tip of an arbitrary rectangle to the axis of revolution, and d omega depends on the orientation of the arbitrary rectangle. So when using vertical rectangles, this d omega here becomes dx, and if we are using horizontal rectangles, d omega is dy. Alright. So how do we know which rectangles are we going to use? Of course, what we're going to have to take note that rectangles should be perpendicular to the axis of revolution. Okay? How about AB? So, ito ngayon yung interval kung saan natin i-integrate yung volume natin. Okay. Now, so let's see kung ano yung gagamitin nating rectangles. So, saan ba natin to isa-set up? So, set up in terms of x or y. So, we need to know. So, tignan natin. Mag-drawing tayo ng arbitrary rectangle na perpendicular dun sa axis of revolution. So, again, this is the axis of revolution. So, kailangan natin gumawa ng rectangle perpendicular to this. So, tingnan natin. So, tayo ng rectangle dito. Okay, so that is, anong klaseng rectangle to? This is a vertical rectangle. Therefore, we need to set up this definite integral in terms of x. Okay, very good. Okay, so now let's find the points of intersection of the line y equal to x minus 2 and the parabola y equal to 2x minus x squared. Okay, so points of intersection. So how do we look for the points of intersection? Ano pwede natin gawin dito? We can use substitution. So this implies that 2x minus x squared is equal to x minus 2. Rearranging this equation, so we get x squared. Lipat natin to lahat sa right side. So x squared minus x minus 2, and that is equal to 0. So we have x minus 2 x plus 1 equal to 0. This means that x is 2 or x is negative 1. Okay? When x is 2, y is 0, when x is negative 1, y is negative 3. So in the graph, we can see that this point here is negative 1, negative 3, while this point here is 2 to 0. So that's how you get the points of intersection. Okay? So makukuha na natin ngayon kung saan mag-run yung interval natin. Okay? So yung AB na interval natin will run from negative 1 to 2. Why? Kasi ito yung mga x coordinates ng intersection natin. So next, let's set up R2, or this is the distance of the farther tip of the rectangle to the axis of revolution. So as you can see here, ito yung farther tip natin. So kapag gumawa tayo ng line from this going to the axis of revolution, that will serve as your R2. Okay, so ito. Okay. So again, how do you get this distance? So it is the upper curve minus the lower curve. So your upper curve is the line y equal to 2 minus the lower curve. So this is the curve which has an equation x minus 2. Okay. So this is equal to 2 minus x plus 2, or this is equal to 4 minus x. So R2 is 4 minus x. How about R1? So again, ito yung mirror tip natin. So R1 is the distance of the arbitrary or the mirror tip of an arbitrary rectangle to the axis of revolution. So let's try to draw a line. Okay. So here, so the upper curve is y equal to 2, and the lower curve is the parabola y equal to 2x minus x squared. So R1 is equal to 2 minus the quantity 2x minus x squared, or this is equal to 2 minus 2x plus x squared. Thus, this is now the equation for R1. Okay. So we can now set up the volume of the solid using washers. Okay. Right. So the volume now is equal to the definite integral from negative 1 to 2 of pi of the quantity R2. So R2 is 4 minus x quantity squared minus R1, which is 2 minus 2x plus x squared quantity squared. And since we are using vertical rectangles, this must be dx. Okay, so let's compute. So this is now equal to the definite integral from negative 1 to 2 pi. So mahabang computations to, but you can verify that this is equal to negative x to the 4 plus 4x cubed minus 7x squared plus 12 dx. So this is equal to pi times the quantity. So the integral of negative x to the 4 is negative x to the 5 over 5 plus the, the integral of 4x cubed is x to the 4 minus 7x cubed over 3 plus 12x. Now this is evaluated from x equal to negative 1 to 2. Okay, so substituting 2 and negative 1 to this expression here leads us to 117 over 5 pi cubic units. So this is now the volume of the solid. Okay. All right. So we're done with the first one. Now let's proceed. For the second problem, we want to set up the definite integral or sum of definite integrals that will give the volume of the solid generated when the plane region bounded by the line y equal to 2x minus 4. So this is the line y equal to 2x minus 4. And the parabolas y equal to 4 minus x squared. So this is y equal to 4 minus x squared. And 2y equal to 4 minus x squared. So this is the parabola 2y equal to 4 minus x squared is revolved about the line y equal to negative 1. Okay. So observe that here, if we try to draw an arbitrary rectangle in this part and another arbitrary rectangle in this part, anong mananotice natin? Observe natin na magkaiba sila ng upper or yung upper curve or yung tip ng rectangles. So ano pwede natin gawin? So what you can do here is to divide this shaded region into two sub-regions. For example, we call this sub-region to be R1 and let's call this sub-region to be R2. Again, ang gagawin natin is to find the points of intersections of this curve. So una, ito. How do we find these points of intersection? I have x is 0 or x is negative 2. So y, when x is 0, y is 4. And when x is negative 2, y is 0. Okay? Actually, dalawa yung nahanap nating points of intersection. Nahanap natin to as well as this one. So at this point has coordinates negative 2, 0, while this intersection here has coordinates 0, 0, 4. Okay? That is for the first two intersections. So how about this one? How do we get this intersection? So to find this intersection here, this is the intersection of the two parabolas. So let's solve this. 0 implies y is 0. So the x value is when y is 0, x is plus or minus 2. Okay? So from this, meron tayong makukuha na 2, 0, and negative 2, 0. So, na-compute na natin. Lumabas na yung negative 2, 0 kanina. So, yung 2, 0 na lang. So, this is 2, 2, 0. Okay? Tulad nung ginawa natin, hinati natin into subregions yung solid natin. So, let's start. So, for R1, what is the interval that we will be using for R1? So, again, dahil ang rectangles natin ay vertical, ang titingnan lang natin ay yung mga x coordinates. It's from negative 2 to 0. What is R2? Again, R2 is the distance of the farther tip. So that is the distance of the farther tip of an arbitrary rectangle to the axis of revolution. So again, upper minus lower. So the upper here is 2x plus 4 minus the lower curve, which is negative 1. So R2 is equal to 2x plus 5. For R1, pwede natin gawin is to look at the near tip hanggang dun sa axis of revolution. But take note, ang near tip natin ay yung parabola na 2y equal to 4 minus x squared. Since these are vertical rectangles, dapat everything must be in terms of x. Okay? So we have to rewrite this in terms of x. So how do you rewrite 2y equal to 4 minus x squared in terms of x only? So divide both sides of the equation by 2. So you get 2y y equal to 4 minus x squared all over 2. So R1 is 4 minus x squared all over 2 minus the lower curve is the line y equal to negative 1. So that is minus 1. So we get 2 minus x squared over 2 plus 1, or this is equal to 3 minus x squared over 2. Okay? So we have now R2 and R1. So this is for R1. So let's... Okay, for R2, our interval AB will be equal to, ito yung R2. So from this point to this. Okay, so AB is from 0 up to 2. Again, x coordinates kasi vertical yung rectangles. So ano naman yung R2 for the second region? So that is the distance of the farther tip to the axis of revolution. So the farther tip is this parabola, y equal to negative x squared. So that is 4 minus x squared minus the lower curve, which is negative 1. So this is equal to 5 minus x squared. And for R1, again, that is the distance of the nearer tip to this. Okay, so similar lang din sila nung R1 nung una. So R1 is equal to 3 minus x squared all over 2. Okay? So we can now set up the volume for... Okay, so we can now set up the definite integral or sum of the definite integrals that will give the volume of the solid. Okay? So the volume now is equal to the volume of R1 plus volume of R2. This is equal now to... So for the first one, ito yung gagamitin natin. So that is definite integral of pi from a to b. So ang a to b natin is negative 2 to 0. So that's from negative 2 to 0 times r2 squared. So that is 2x plus 5 squared minus r1 squared, which is 3 minus x squared over 2 squared dx plus... So here the definite integral from... So sa r2 naman tayo. So this 0 to 2 r2 squared, which is 5 minus x squared minus 3 minus x squared over 2 squared. Okay? So this is now... This is now the volume or the definite integral that gives the volume of the solid. Okay? Okay, so we're done with the first two examples. Now, this will be the last. So set up the definite integral or sum of definite integrals that will give the volume of the solid generated when the plane region bounded by the curve y ln 3 equal to ln x plus 1. So this is this curve. And the lines x plus 2y equal to 0. So this is that line. And y equal to x minus 6. This is this line. Is revolve about the line x equal to 8. So saan natin to dapat i-set up? Again, para malaman natin kung saan natin to i-set up, the rectangles that we will be using needs to be perpendicular to the axis of revolution. So if this is the axis of revolution and this is our region, so tingnan natin kung ano yung rectangles na kailangan. So what can you say about this rectangle? This rectangle is a horizontal rectangle. So we need to set this up using y. Okay? So in this problem, binigay na yung intersection. So hindi na natin kukunin yung intersection. Ano na lang importante dito? We need, since we are setting up our definite integral in terms of y, everything must be in the form f of y equal to x. So ito yung gusto natin. Okay? So, ano ba yung tatlong equations natin dito? So, the first curve is y ln 3 equals ln x plus 1. So, dapat masulat natin siya sa ganitong form. So, I need to solve x in terms of y. So, how do we solve that? Okay. So, from here, we know that this is equal to e to the y ln 3 equal to x plus 1. So this means that we have e to the y, e to the ln 3 is only 3. So this is equal to x plus 1. Okay? So this means that x is equal to 3 e to the y minus 1. Okay? That means the curve here, that means this curve has this equation. Okay? Sulat natin yan. So this is the same as x equals 3 e to the y minus 1. Okay? So how about this? Number 2, we have x plus 2y equal to 0. So we have to solve for x. This is easy. X is simply equal to negative 2y. And lastly, so meaning this is just x equals negative 2y. Lastly, we have y equal to x minus 6. Again, this is easy. So you have x equal to y plus 6. This is x equals y plus 6. Bakit ulit natin ito ginawa? Because we are using horizontal rectangles. Okay? So just like what we did in item number 2, we'll divide this into 2 partitions or into 2 subregions. So this is R2. Let's call this region R1. Why? Because if we draw arbitrary rectangles here, what can you see? Magkaiba sila ng bounds. Okay? So hatiin natin. Okay, so for R1, ano ang interval AB natin? Okay? Since we are using vertical rectangles, dapat nakatingin tayo ngayon saan? Sa y coordinates na. Okay? So take note that this point here has coordinates 0, 0. Okay? So it's from sa y na tayo dapat nakatingin. It's from negative 2 to 0. Okay? How about R1? R2. So R2 ay distance ng farther tip hanggang dun sa axis of revolution. So kapag ganitong orientation, how do we find the length from this point to this point? So that is the right curve minus natin yung left curve. Okay? So R2 is equal to, ano yung right curve natin? It's 8. The right curve is this line, while the left curve will be this, which has an equation x equal to, so ito, x equal to negative 2y. Okay? So minus negative 2y. So this is equal to 8 plus 2y. And for R1, ganun ulit, right minus left. So, to yung right curve natin, ang magiging left curve natin ay yung mirror tip, which is this. Okay? So, ito yung gawa tayo dito from here to here. So, that's 8 minus this line, but this is the equation of that line. So, that is 8 minus the quantity y plus 6. Therefore, this is equal to 2 minus 2 minus 6. This are R1 and R2. Okay? Now, for R2, ano yung interval AB natin? So again, dahil horizontal rectangles to, dapat nakatingin na tayo sa y coordinates. So 0 to 2. Okay? 0 to 2. R2 is equal to, so right minus left, right, tapos dun sa, right, tapos dun sa farther tip, which has this equation. So you have 8 minus 3e to the y minus 1. So this is equal to 9 minus 3e to the y. And for R1, actually same sila nito kasi parehas yung lower bound nung rectangles nung parehas na region. So, R1 is the same as this one, which is 2 minus 1. Okay? Okay, so we can now set up the definite integral. Okay, so we can now set up the sum of the definite integral, or sum of definite integrals, that will give us the volume. So V, again, is equal to VR1 plus VR2. So this is equal to the definite integral from -2 to 0 pi times R2 squared. So that is 8 plus 2y quantity squared minus 2 minus y quantity squared dy plus definite integral from 0 to 2 pi quantity R2 squared. So, R2 natin ay 9 minus 3e to the y squared minus quantity 2 minus 5 squared dy. Okay? So, this is now the sum of the definite integrals that will give us the volume of the solid generated by displaying region. Okay, so that's it. Thank you for listening and good luck.